Hello everyone. In today's class we are going to discuss crystallographic planes. Crystallographic planes. In last class we had discussed crystallographic directions, in which we had found out a way to locate different points and different atoms in a crystal lattice. In today's lecture we will find out a way to locate the different planes in a unit cell, right? So here what we are going to do, we will have one unit cell. हमारे पास एक unit cell होगा, okay, and here we will have to find out a way to locate different planes. In our earlier class we had located different points and different atoms in a unit cell. Today we will locate different planes in a unit cell, right? So let us suppose that we have to locate this top plane. Okay, this is our graph. This is x-axis, this is y-axis, and this is z-axis, right? And we have to locate this plane which is at the top face. So here also we will have to follow certain rules. The first rule is to find the intercept made by the plane on all the axes. See, this is our plane. Whatever this plane is making intercept on all the three axes, write down those, all the three intercepts. The second step is to take reciprocal of the intercept made by the plane. First of all, we will find out the intercepts, and the next step is to find out the reciprocals of the intercept. And the third is simplification if required, right? So let us suppose that the edge length here is a, right? So let us talk about this plane a, b, c, d, which is also shaded in this figure. So what is the intercept made by this axis on x, what is the intercept made by this plane on x-axis? Is this plane intersecting with the x-axis? No, it is not intersecting anywhere with the x-axis. Why? Because this plane is parallel to the x-axis. So it is going to meet the x-axis at infinity. If it is parallel to the x-axis, then it is not making any intercept. It means that it will meet the x-axis at infinity. So its intercept on x-axis is infinite. Now, what is the intercept made by this plane on y-axis? So you will see that this plane is also parallel to the y-axis. It is not making any intercept on the y-axis. That is, it is going to meet y-axis at infinity. So its intercept on y-axis is also infinite. Now, this plane is intersecting the z-axis. It was not intersecting the x-axis. It was not intersecting the y-axis because it was parallel to the xy plane. But this plane is intersecting the z-axis. And where is it intersecting the z-axis? It is intersecting at an intercept of a. So first of all, replace this a by 1. Okay, this is infinity, and this is 1. Now the second step is to take reciprocals. So when you will take reciprocal, then this 1 by infinity will convert into 0. Again this 1 by infinity will convert into 0, and 1 by 1 it will lead to 1 only. Now here we don't need any simplification because already we have all the three Miller indices in the form of smallest possible integers, right? So these three numbers which we get here are the final Miller indices indicating the location of this particular plane. So when we will write these three numbers in a curly bracket or in a parenthesis bracket, then these three represent the Miller indices for this particular plane. Now let us look at one more example. Suppose that this is our unit cell, right? This is our unit cell, and this is our these are our axes x, y, and z, and we have to find out the Miller indices for this plane, right? We have to find out the Miller indices for this plane. So how can we find out? Again, we have to follow these three rules. First of all, we will find out the intercept made by this plane on the three axes. We will find out the intercept made by this plane on x-axis, y-axis as well as z-axis, right? So you can see that this plane is not intersecting the x-axis. It is not intersecting the x-axis. It is intersecting the z-axis at a distance of a. It is intersecting the y-axis also at a distance of a, but it is not intersecting the x-axis. It means that this plane is going to meet the x-axis at infinity. So what is the intercept made by this plane on x-axis? It is infinite. Now what is the intercept made by this plane on y-axis? See, if the edge length of this cube is a, the intercept made by this plane on y-axis is equal to a. What is the intercept made by this plane on z-axis? It is again equal to a. So we have found out the intercept made by this plane on x, y and z axes. Now the next step is to replace the parameter with 1, right? So we replaced it with 1. The next step is to find out the reciprocals of these intercepts. So 1 by infinity becomes 0. 1 by 1 becomes 1 and 1 by 1 becomes 1, and again we don't need to do any further simplification because we already have these three numbers in the smallest simplified form. So when we put these three numbers inside the parenthesis, then these numbers indicate the Miller indices for this particular plane. Okay, I hope it is clear to you. Now let us take one more example. Suppose that this is our unit cell, and we have to locate this plane. Okay, this is our plane, this is our graph x, y and z axis. This is our unit cell and this is the plane which we have to locate using the Miller indices. We have to find out the Miller indices for this particular plane. Again, the edge length of this cube is a. So the first step is to find out the intercepts made by the plane on x, y and z axis. So what is the intercept made by this plane on x axis? It is equal to a. This is the intercept it is making on the x axis. So the intercept made on x axis is equal to a. The intercept made by this plane on the y axis is also equal to a, because this length from here to here, the intercept it is making on the y axis, this length from here to here is equal to a. And again the intercept made by this plane on the z axis from here to here is equal to a. Now the next step is to remove the parameter with 1, replace the parameter with 1, and then we have to take the reciprocal. So the reciprocal of 1 is again it is equal to 1, and it does not need any further simplification. So when we put these three numbers 1, 1 and 1 inside the parenthesis, then it finally represents the Miller indices for this particular plane. Now let us see one last example. This is our unit cell. These are our reference axes x, y and z axis, right? What if we have to locate this plane? These points are at the middle of the three edges. This point is at the middle of this edge, middle of this edge and middle of this edge, and we have to locate this plane using Miller indices. So how can we do that? we will have to find out, first step is to find out the intercept made by this plane on x, y and z axis. So how much intercept this plane is making on the x axis? It is equal to a by 2. Why? Because this point just lies at the middle of this edge. The intercept made by this plane on y axis, it is also equal to a by 2. The length from here to here, it is also equal to a by 2. And the intercept made by this plane on z axis, it is again equal to a by 2. The next step is to replace the parameter a with 1. So this becomes 1 by 2, 1 by 2 and 1 by 2. Further step is to take reciprocal. So the reciprocal of 1 by 2 is equal to 2, 2 and 2. And then the last step, which is of simplification. What we can do here, we can divide the three numbers with 2. If we divide them with 2, then what do we get? We get 1, 1 and 1. Right? So when we put these three, 1, 1 and 1 inside the parenthesis, then what do we get? We get the Miller indices for this particular plane. Now there is one very interesting thing happening here, that the Miller indices for this plane is 1, 1, 1 and the Miller indices also for this plane is 1, 1, 1. Now why it is happening? So this is happening because these two planes are parallel to each other. That is why their Miller indices are same. Now let us take one more example. Suppose that this is our unit cell. Right? This is our reference axis, x, y and z. Now suppose that we have to locate this plane, the plane which is connecting these 3 points. Right? This point lies at the lies at a distance of twice the distance at which this point lies. Yani if this is A, then this is also A. Right? So we have to find out the Miller indices for this particular plane. So what is the first step? The first step is to find out the intercept made by this plane on x, y and z axis. What is the intercept made by this plane on x axis? See, if you are not able to see it, then let us start it again. First step is to find out the intercept made by this plane on x, y and z axis. So what is the intercept made by this plane on x axis? It is equal to a. Right? What is the intercept made by this plane on y axis? From here to here, it is 2a. And what is the intercept made by this axis on this plane on z axis? It is equal to a. See, we have found out the intercept made by this plane on x, y and z axis. The next step is to replace the parameter a with 1. Right? The next step is to take reciprocal. So let us take the reciprocal. Reciprocal of 1 is 1. This becomes 1 by 2 and this becomes 1. Now the last step is simplification. For simplification, what we have to do? We have to replace this fraction. How can we replace this fraction? This fraction can be replaced if these three numbers are multiplied with 2. So 1 into 2 becomes 2. Half into 2 becomes 1 and again this 1 into 2 becomes 2. So finally we get 2, 1 and 2. When we put these three numbers inside a parenthesis, then this represents the Miller indices for this particular plane. So this was all about crystallographic planes in which we found out how to locate different planes using their Miller indices. I hope this would be clear to you. But even if you have any doubt, then do comment in the comment section below and I will reply to your doubts. Okay. But if you find that these videos are useful for you, you are able to understand the concepts of material science, then please share it with those students who have difficulty in material science, because material science is such a subject which is not taught very well in our colleges, and it is also one of those subjects which compel a sincere student to go to coaching classes. So if you find that these videos are helpful for you, then please share this video with those students. Right? Thank you for watching my video. I will see you in next video. Okay, thank you very much.